the head of autonomous vehicle tech of Thoughtworks. Michael, welcome.
Thank you. Guten Tag. I'm fully aware that it's me between you and the networking drinks. I promise I'm going to make it short while. I'm going to go at fast pace. Yes, my name is Michael. I'm a software developer. I've been working with Thoughtworks for 12 years. My background is clearly in the web and in the cloud world, but for the last 5 years, I've been only working automotive. And it's interesting that Mr. Zenger spoke right before, because I spent 2 months last year next to this bus you just seen in the talk before, and it was a love and hate relationship. But I can confirm everything that you saw is happening. I'm a software developer. I'm going to speak about software development. Don't worry, it won't be about specific technologies. It's going to be approachable for everyone. In 2021, the article from IEEE came out, Software is Eating the Car, describing every generation of new cars will have more and more lines of code. The challenge is making a start of production get higher and higher. And in the last couple of hours, we've been using this term, software-defined vehicle, more and more. And I guess that's the optimistic way to look at it, where software becomes the differentiating factor of the functionality of cars. It's pretty obvious, right? World-class vehicles need world-class software, and this needs world-class software development. And this is what I'm going to talk about. Because when you think about the implication that a software-defined vehicle has for the car and the software development, actually quite a lot of things have to come together. So on the in-vehicle side, you have to have over-the-air updates, you have to decouple the hardware-bound software from the functional software. The ECU architecture is changing with every generation. And we really have to convince ourselves to put high overpowered hardware into the software, because what's the use of over-the-air updates when the current hardware barely holds the functionality it has? And we have to explore new technology stacks. And if you're wondering why there's an orange crab next to that, talk to me afterwards. I'm not going to speak about all those things on the left-hand side because they are on a talk on its own. What I'm going to speak about is the software development, because there the implications for a software-defined vehicle are very significant as well. We have to decouple the development cycles of hardware and software, which is a challenge on its own. And we have to come to a more iterative process how to develop software for the car. Or to phrase it slightly differently, just accept the fact the software for a car will never be done. It's not finished. We have to continue. We need a new dimension of virtualization and automation. And what's very significant, at least from my experience with the German automotive industry, we have to find different collaboration models between all the partners coming together. They need to be more iterative, closer, and more frequent. And as we've seen before, and I can confirm everything Mr. Zenger said about this project, there are good examples of innovative and modern software development in the automotive industry. However, the established standard process how to do software development I have seen, or we have observed, is not ready for software-defined vehicles. It feels like a bit like what William Gibson said. The future is already here, but it's just not equally divided, right? So what we see is, for the business-as-usual software development for embedded systems, we see lots of full upfront design. We see that developers can't even experience what the lines of code are doing. I've talked to developers and they say, I've never seen this working in a real car. We have irregular and infrequent updates and very long feedback cycles. And even though you might not, code for a living, finding bugs late in the game, finding change requests late in the game, that's really costly. What I've seen also is a lot of artifacts are throwing over the fence. Here are the requirements, here's the software design, here's some code, here are the tests. And people don't really collaborate, which means cycle times will always take very long. And it seems not only that task forces are a common method for projects, it seems at some companies you earn your badges by rescuing the project. And this is just not sustainable. We've seen this before. I'm a tiny bit too young to have experienced big software projects in the late 90s, but when I started to develop software, long release cycles and the quote, never touch a running system, code freezes and big bang deployments were still around. And that was the time where we saw those books were written, The Mythical Man Month and The Death March Project. And at this point in time, people started to ask, how can we make software development less painful? And clearly it started with Kent Beck at the extreme programming practices. How can we eliminate waste from software development? And in 2001, the Agile Manifesto was written. This then, it took almost 10 years, right? At a conference, Patrick Dubois said for the first time the term DevOps, and what he meant by that was we have a gap between development and operations, and how can we cross this gap? How can we make it more fluent in that case? And 1 year later, the book Continuous Delivery by J.S. Humble came out, and Mr. Farley. It took another 10 years that those books came out. The DevOps Handbook and the Accelerate, which is one of my favorite books. Please buy it, read the first 100 pages. You don't have to read the second 100 pages because they're just explaining why the first 100 pages are correct. It's a very US-American book, very easy to read. And I guess the common pattern, I don't want to talk about development and operations because in the automotive industry it's far bigger and more complex. But there are principles that came out of this to focus on. So if you think about DevOps, don't worry about operation. It's all about speeding up the flow of software development from feature request to production and focus on a seamless flow in that process. So that's the forward, right? And the same backward, shortening the feedback loop through all stages of the development process. The earlier you know that the line of code you've written, the better it is. Or the earlier you find it's not good, the better it is. And then probably also the interesting aspect is build a learning organization that continuously improves the processes and tools. It's normal for modern software development teams to question every week, what can we do differently? Can we write a script that makes it better? How can we collaborate closer? And when I preach all this in the automotive industry, I hear, hold on. This is interesting. Can you trigger this? Because it changes here, it doesn't change there. Your agile schmoo doesn't work here. Schmoo is a German word for nonsense, or maybe even snake oil if you want, right? Because what we are doing here, that's functional safety. This is critical, right? Go away with your infrastructure as code. It does not work here. And it's interesting because I'm not suggesting at all that we should eliminate the artifacts that come out of a V model. What I'm saying, if you think about the three principles, how can we achieve all the artifacts that come out of this process in a more iterative and frequent way? Because nowhere in the ISO 262 it says upfront design, or nowhere in the A-Spice model it says waterfall. The opposite. A-Spice Level 5 basically describes an agile process that ensures the same quality. And this is what we want to do. Please don't read all this. But this is a quote, or this is an extract from ISO 26262. And it does mention even agile software development. It gives test-driven development as an example. And it says continuous integration can help you to fulfill all these things. And even if you say, are still agile schmoo to me, right? I mean, we can at least agree that these principles and thriving towards these would be a desirable thing to do when software becomes more complex and when software is never done, even for a car. And I'm not suggesting that we just take the book and the methods that come out of the web and cloud development and just try to apply them one by one. No, we need to find our own thing. We need to find our vehicle DevOps. And I guess it takes more than just the one process or the one way, because there are multiple things you have to consider. One are technology drivers. Second thing is capabilities and people. And the third one is organizational adaptability. That's a very hard word for German. I'm going to quickly run through all of those because I don't have much time. When it comes to the technical drivers, I don't think there's a single concept or thing that people haven't tried. But sometimes it feels like you are doing the right things, you're not doing them right. And let me give you just a few examples. When I ask a company, are you doing CI, continuous integration? Yes, we do that. And if we now look at the definition, how it is in the big video, it's the practice of merging all developers' working copies into a shared mainline several times a day. Merging all developer copies several times a day. Are you still doing continuous integration, or are you just handling in an automated way long-lived feature branches and you try to integrate them every 6 weeks? Because that's the more common thing. And same goes for example, testing. Testing should be done by the development team in parallel to the development they do. But what I've seen is, oh yes, we write unit tests 4 months later by a different team on a different continent, because the Western salaries are just too expensive to let them write tests, right? But if you do that, you gain all the effort you have from tests without getting the benefit while you're doing the development. You don't have the safety net anymore. You can't do refactoring in a safe way. You just have, to be honest, the test coverage you need for the audit. And similar things go to pipelines and self-service. I'm just going to do self-service. Yes, we have a team that provides, I don't know, licenses, tools, whatever. I need GitHub Actions, or I need a repository, or I need a VM or remote hardware. Yeah, write a Jira ticket and then wait, right? So if you really want to empower big organizations of making efficient development, right, these things need to be ticketless and self-service and used by the development teams like they are in internal product. I wish, as a software developer, that software development would be an art, but it's not. I wish it would be more scientific, but most of the time, unless you develop cutting-edge AD software, it's not. 95% of software development is craft in the sense of the German word Handwerk. And you need to learn craft. It takes time. You need to learn the tools. You need to make mistakes. And it just, you need to try out stuff. And this in combination, just realizing the fact with what we observe a lot in the automotive industry, that we have I-shaped people. And don't get me wrong, this is not at all meaning in a condescending way. I-shaped meaning specialist in one domain or one technology, the expert because this person has done sensor fusion for the last 10 years, or the expert in MATLAB and Simulink code generation. But what it needs to apply, this flow and modern software methodologies is what we call T-shaped people. You need a set of broader skills. Running a Docker container, tweaking your Git configuration without a graphical tool, write some Python code that doesn't fall apart next week. And we need to give people time to learn those things. When it comes to the organization, I just want to highlight 4 things, and every single thing of those is a talk on its own, and I'm happy to discuss this all after this talk. One thing is, as an organization, for a significant part of your software development, you want to thrive for cross-functional autonomous teams. Cross-functional in the sense is in the team all the capabilities and roles you need to fulfill, writing this software, meaning it's not only developers in one PO, right? You might need a requirements engineer. You might need a functional safety expert. You might have a specialist for testing. And I think there companies make significant improvement, but just measure the time. It still takes forever. Another one is team topologies. That's a book that came out 2 years ago. I'm not going to go into detail of that, but it just describes there are different types of teams. And different types of teams have to collaborate in a different way. Sometimes you want this ticketless self-service. Sometimes you want physically close collaboration between teams. And I think the more deliberate you are when you design your team cut and how they interact, the more efficient the development will be. Another one is inverse Conway law maneuver. I'm sure lots of people in the room have heard Conway's law, which means eventually your software design will look like the communication structure in your organization. To make it simpler, likely your software will look like your org chart at some point. But we can twist this, because this is a natural way how software develop because of the communication flows. If you think first about the architecture of an ECU or cross-ECU or a piece of software, and you say, these are good boxes, they belong together, and these boxes should have an interface between each other, how about then you make your team structure and your communication structure in the organization according to this architecture? Because it will be much easier to fulfill that. Like we saw in the talk before with the 4 layers. They should be independent of each other. So likely when you have a level 1, 2, or 3, 4 team. Well, not sure if that's the best way. Last point is, be agile, don't do agile. I have seen so many times, either we are agile or we tried agile and it doesn't work, but what you saw is that they hired 2 consultants, implemented a SAFe framework on a program level, and renamed some of the meetings, and then said we're agile. But if you don't change how the people think, how they work, what the capabilities are, you get what we call agile theater. Basically, there's a Gantt chart with the whole program in the back, and you're just translating certain bars in the Gantt chart into the slang of agile. And this brings me to the last point, because I cheated in the beginning. I think there's a very fundamental thing. A change in mindset. I hear so often, oh, we're actually making progress here, we're actually doing good, but we still have to think more like software developers. We still have to become a more agile company. And changing culture is very hard, right? But I think a few things might help. So if you think about culture, that's the basis, right? That's where you derive the values of individuals and teams. And these values basically then make implications for their actions and the behaviors you do. And I think if you really want to change your mindset, you should just go the opposite way. There's probably a scientific term for that. But if you change the behavior, eventually your values might change. Eventually the culture of your team or your department or your company might change. And addressing the managers and the leaders now in the room, it's up to you to make the boundaries and the goals and the incentives to change these behaviors. Let me give you an example. I haven't heard in any domain the sentence so much as, this doesn't work here because, right? And to be honest, the people are right, because what we ever discussed, right, doesn't work because. But I rarely hear, how can we achieve that? And I wish people would be forced just to repeat the same thing they wanted to say, but they have to start with, how might we achieve that? The second thing is, measure in the dimension you want to improve. If you want to see working software, just make it a rule. Next showcase, we are not going to look at slides. Next showcase, we're only going to look at the test bench or the virtual environment or the prototype car. Anything else doesn't count. Or if you worry about the lead time, which is one of the desirable things, from a code change to it ends up in the closest thing you have to production, which is usually a prototype car, measure it. Does it take now 6 weeks? Okay, let's improve on that. Let's make it 4, right? And then make it 3 and 2. Because eventually we want to be able to deploy software to a software-defined vehicle within days and not years. The last thing is so important. Allow for and invest in incremental improvement. I've heard so many times, please don't disturb the developers. They have an SOP, right? And then it feels to me like a bit, oh, I don't have time to sharpen the saw. I have to cut so many trees. And even if that, right, I mean, I get, sometimes in a project it's like very tight, right? But what comes after this SOP? The next SOP, because that project is also already late. This is just an overview of the things. I think, to me, it's 100% inevitable that we have to focus, if we want to unlock the values of software-defined vehicle, that we have to focus on these principles when it comes to software development. These are just guidance blocks you have to think about. And I'm not selling a product or a service here, right? It won't be easy. It will take time. Probably for companies it will take years and maybe a decade. And not all of them will change, right? There will be blood and sweat and tears. Hopefully not blood. But to end on a positive note, For me, as a developer coming from the cloud and web world, the first time somebody pressed enter in Berlin and in Stuttgart, the window was rolling down, or the first time we saw the Moya vehicle going through the sensor, through all the layers that Mr. Zanger just described, to the front end of the remote operator, that's so fulfilling. And I think that a lot of companies in the automotive industry have the potential to become a go-to place for young developers who want to learn and just do amazing stuff. That's all I wanted to say. Thank you. Thank you. No time for questions?
Absolutely. Do you have any questions? Please go ahead.
That's all right, everybody wants to go to the drinks. I'm going to be around, I'm going to be at the booth. If you say, Michael, this is all nonsense, we figured it out, please tell me about it. If you want to hear more about those things, also please just ask me. Thank you.
So that concludes day 2. Day 1, should I say. So day 2 kicks off tomorrow, so please do come tomorrow. It's not the end of the conference. We'll be starting at 8 a.m. with a breakfast workshop hosted by NordCloud. So if you would like a seat, you're definitely going to need to arrive promptly because there's been a lot of registrations for it. So if that's of interest, please arrive promptly. But I'll see you all tomorrow. Thank you.